Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the third numerical on detection and estimation. Please note this is a numerical on maximum likelihood receiver. Let me read out the question first. A discrete source has 8 symbols M1, M2, etc. till M8 and the corresponding transmitted signals are given as S1 of t, S2 of t till S8 of t respectively. The signals are equiprobable and the channel is an AWGN channel. The signal vectors are points in the three-dimensional Euclidean space with coordinates as given below. S1 equals 0, 0, 0, S2 equals 0, 0, 1, S3 equals 0, 1, 0, S4 equals 0, 1, 1, S5 equals 1, 0, 0, S6 equals 1, 0, 1, S7 equals 1, 1, 0, and lastly S8 equals 1, 1, 1. If the received signal vector x equals 1 by 4, 5 by 4 and 3 by 4, determine the decision of the detector if the receiver is a maximum likelihood receiver. Right, let us start with the solution part. First of all, let us understand the question. We are told there is a discrete source that produces 8 symbols. So, I will write them as M1, M2, M3 till M8. And each symbol corresponds to a signal given by S1 of t, S2 of t, S3 of t till S8 of t. These signals are told to be equiprobable. That is an important point. And they are all transmitted through an AWGN channel, which is additive white Gaussian noise channel. We are told the signal vectors are points in the three-dimensional Euclidean space. Therefore, the dimensionality of the constellation diagram is 3. And lastly, we are given the received signal vector x, which is given as 1 divided by 4, 5 divided by 4 and 3 divided by 4. We are told the type of the detector is the maximum likelihood detector. Right. The question is, when the given signal vectors are so and so as defined in the signal vector shown in the numerical, and if the received signal vector x is given as once again in the numerical, what will be the decision made by the maximum likelihood receiver? I have already created a video on the working of the maximum likelihood receiver. If you have not yet watched that video, I highly recommend you to watch that. You can click the link shown on the top right corner right now, or I'll leave the link of that video in the description below. This problem can be solved by using the decision rule, which is directly taken from the maximum likelihood receiver part and is given by yk equals summation j varying from 1 to capital N xj into skj minus of 1 divided by 2 into ek. This is for k varying from 1 to capital M, where M represents the total number of input signals. For this case, M equals 8. Now, what we are supposed to do is to compute the value of this scalar yk and choose the corresponding symbol mk or the corresponding signal sk that produces the maximum value of yk as the decision. In simple words, I can now say the estimated value of the symbol will be that particular symbol which produces the maximum value of yk for the value of k varying from 1 to capital M. Let me write down that sentence here. Right, that is how you are going to find the decision of the maximum likelihood receiver. Let us now come back to the equation for yk here and understand its components. The first term in the RHS of yk which is xj multiplied with skj, is the inner product of the values xj and skj. Coming to the second part, which is Ek, it is the energy of signal Sk. Please note the energy of the signal in terms of its coefficients Skj can be given as summation j varying from 1 to 3, because it is a three-dimensional signal space, Skj square. Before computing Yk, what I will do is I will show how to compute the value for the energy of each signal. The energy of the signal is given by the expression here. So, energy of the first signal is E1 and is equal to summation j varying from 1 to 3 S1j square. Okay, so it will be equal to S11 square plus S12 square plus S13 square. Now, what is S11, S12, S13? They are the values of the coordinates for S1. You can look at this. S11 is 0. So, I can write it as S11, S12, S13. Okay. So, for S1, it is 0, 0, 0. So, come back and substitute. This is 0 square plus 0 square plus 0 square. Therefore, it will be equal to 0. Similarly, the value for energy of the second signal S2 of t is given by summation j varying from 1 to 3 S2j square. This is equal to, as per the vector given, 0 square plus 0 square plus 1 square. So, this is equals to 1. In a similar fashion, we can find the values for the energy of the remaining signals as right. So, these are the values for energy of each of the given signal. Let us now use the expression for Yk and compute the values for the same. So, I am going to rewrite the equation for Yk once again here. Please note, I have already explained the first component is nothing but the inner product of the vector xj and skj. Therefore, I can write this also as x transpose into sk minus of 1 divided by 2 into ek. Once again, k varies from 1 to 8. This representation is a lot easy because now we can substitute the values for x and sk directly into the equation. So, let us start with k equals to 1. So, y1 is equal to x transpose, which is 1 by 4, 5 by 4 and 3 by 4 multiplied by S0 minus of 1 by 2 into E0. So, this is equal to 1 by 4, 5 by 4, 3 by 4 multiplied by S0 is the column vector 0, 0, 0 minus 1 by 2 into E0 is 0. Therefore, the answer for Y1 is 0. Let us now in a very similar fashion compute the remaining elements. Y2 is equal to 1 by 4, 5 by 4, 3 by 4 multiplied by the column vector for S1 0, 0, 1 minus 1 divided by 2 into energy of the first signal, which is 1. This simplifies to 3 divided by 4 minus of 1 divided by 2 equals to 1 by 4. Similarly, Y3 can be computed as x transpose, which is 1 by 4, 5 by 4, 3 by 4 multiplied by the vector S3, which is 0, 1, 0 minus of 1 by 2 into energy of the third signal, which is equal to 1 again. So, this will reduce to 5 by 4 minus of 1 by 2 equals 3 divided by 4. In a very similar fashion, let me compute the rest of the elements. Right. So that is the computation of yk for k varying from 1 to 8. Now, as I have previously said, the decision of the maximum likelihood receiver would be that symbol mk which produces the maximum value of yk. Now, analyzing the answers for y1 to y8, we find that for k is equals to 4, yk is maximum. Therefore, the maximum likelihood detector decides in favor of the signal S4 of t or symbol M4 as the transmitted symbol. Right. So that is the answer for this numerical. Well, if you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.